Hello, my name is Gevorg, and I'll walk you through my implementation of the Tetris game. I completed milestone 5, and I decided to do 6 easy features and 1 hard feature. From the easy features, I did gravity, acceleration and gravity, the game over screen, sound effects for horizontal collision, rotation, Tetronimo landing, pause screen, and starting with 5 random unfinished rows. For the hard feature, I decided to implement the background music Karabeiniki. So here on the right side you can see the grid, which is 10 by 20. For the bitmap display I have 160 by 192, and the units are 8, so 8 by 8. And for each block on the grid it's 4 bytes. For the display address and the keyboard address, they are the same as they were given in the assignment, and I also added the address grid start, which is the address of the top left block in the grid, so the very first block in the grid. For game state variables, I have X pause, Y pause, and orientation for X, Y positions, and the orientation, which is the 4 different rotations of a tetromino. And I decided to do the L shape with a blue color. And then we have the game state array, which is a 200-word array, so 10 by 20, corresponding to the actual grid. And each tetromino is held in memory as a 16-bit pattern. So there's 4 different rotations, so 4 different 16-bit patterns, and the X pose, Y pose, and orientation, basically they correspond to the top left of the 4x4 grid of the 16-bit pattern. So now let's walk through some key routines. First, we have collision detection. The way it works is when a player tries to move or rotate, we load the 16-bit tetromino pattern and then loop through each bit. For every bit, if it's 1, then we calculate the appropriate coordinates according to the shape, according to the pattern. So we add the row and column offset to the tetromino's current position, and then we check for if the coordinates are within the bounds for horizontal collision, and also we check if the game state array at that position is empty. So there is no vertical collision, and it returns 1 if there is collision, 0 otherwise. Then we have the handle input function, which uses collision detection in it a lot. So the way it works, it constantly checks at the keyboard's address for keyboard data, and when it detects a key press, it reads which key was pressed and calls the appropriate function. But before actually doing the appropriate action, it checks for a collision, and if there are no collisions and it's safe to move there, then the action is completed. Then we have the update game state. And this is called when a piece can't fall anymore, so it needs to land. And the way it works is we take the current falling tetromino and permanently place on the game grid by writing the blue color values to those positions in the game state array based on the pattern. And after making the piece permanent, we clear any full rows and spawn a brand new tetromino at the top of the screen, of the grid. And lastly, I have the gravity function, apply gravity. And the way I implemented gravity is I store the last drop time and compare it to the current time from the program start using syscall30. And when this interval passes, it calls the move down function, so it drops automatically by 1 unit. And in order to implement the acceleration after each drop, the interval decreases by 5 milliseconds, so every time it's faster until it reaches a minimum interval, and that's when it drops the fastest. And now let's see how we play the game, the basic functionalities. We start the game. We can hear the music, we can go right, left, down, we can rotate. And now let's place this here. We can hear the sound for placing it there. there's also the sound for horizontal collision, as you could hear right there. Now let's just try doing row elimination to see if it works or not. Okay, yeah, we can see that it works right there. And now if we pause, it pauses the game, and when we hit P again, we resume at where we left off. You can also see how the pieces start to drop faster now compared to the start of the game. And now let's also try to do the game over the game over screen that I implemented. We can hear the sounds. It was pretty hard to do the game over, but here we are, and we can see it moves very fast here, and now we hear the game over, and when we press R, it restarts, and that is all. Yeah, that's it for the game, and thanks for watching.